Let's go over some ratio review before our unit test. I'm going to do a few examples of all the different strategies of problems for solving ratio word problems. In teacher problem number 1, I'm going to use a double number line. When you're drawing a double number line, first thing is you're going to draw 2 straight lines, and you want to identify in the information what is being compared in this ratio. So we're comparing 7 birds to 2 hours, and I'm going to label each line with one of those. So B is going to be my first line for birds, H will be for hours. The first set of numbers is the information you are given, so 7 for the bird line, 2 for the hour line. We're going to use this to determine how long it's going to take for 28 birds. So on my number line, I'm going to continue counting until I get a value of 28. So we're listing out our multiples of 7. Once you get to 28, you can stop. On the hours line, you're going to put a tick mark underneath each of the numbers above, and we're going to skip count by 2s. The answer to the question is going to be what comes underneath the information that you are looking to solve. So underneath 28, we end up with 8 hours. The next thing we've talked about in this unit is using ratio tables. I'm going to show you 2 approaches to completing these 2 question marks in the ratio table. First, I'm going to take out from the table the original ratio, and I'm going to write it as a fraction. So we have 5 dogs to 8 cats, and I'm going to solve for an equivalent fraction when I don't know the number of dogs and I know there are 72 cats. In equivalent ratios, just like fractions, you can multiply or divide. And I want to identify what I'm doing to my original ratio, 5 to 8, to get to 72. Okay, 8 times 9 will give me 72. So to fill in my question mark, I'm going to do the same thing to the 5, the number of dogs. 5 times 9 is 45. I can also indicate this in the table using arrows. So when I'm solving for the second question mark, I'm going to show the relationship between the original ratio 5 to 8 and 65 to question mark with an arrow. I'm increasing in value, so I know I multiplied 5 by something to get 65. To determine what I multiplied by, I'm going to take the new amount, 65, divide it by 5, and that tells me I multiplied by 13. And so I'm going to draw an arrow from the cat box, and if I multiply by 13, I will also multiply the cat value by 13. 8 times 13, in the box will go 104. Teacher problem number 3, I'm going to solve using a tape diagram. As I read through the information, I'm going to highlight the important information to creating the diagram. To mix the perfect chocolate milk, you are going to use 3 parts chocolate to 9 parts milk. That's the ratio. If you want to make enough so you have 48 in total, how much of each ingredient? To make a tape diagram, you're going to take both of the values in the original ratio, so 3 and 9, and draw them as boxes. So the first one is 3. I have 3 boxes, and that represents C for chocolate. And then underneath that, my diagram is going to have 9 boxes. And that will represent the milk. 7, 8, and 9. And M for milk. Then drawing on the table, I'm going to determine what this piece represents. So if you are given a total, that is going to be the combination of both of these items. I'm going to combine chocolate and milk together, and I want 48. If I count how many boxes I have, so combine chocolate and milk, I see I have 12 boxes. So when I go to find the value on the inside, I know that it can't be 1 because that would be 12 and the total we're looking for is 48. To figure out the value of one of the boxes, in my calculator I can take the total amount, divide it into the number of boxes you have, 48 divided by 12, and that tells you the value inside each of these boxes. So for chocolate, we have 3 boxes of 4, so we should have 12 parts in total for chocolate. For milk, again, each box is worth the same in the whole diagram. And for milk, we have 9 boxes of 4. 9 times 4 is 36. Teacher problem number 4, we want to know which of these are equivalent to the ratio 3 to 4. To prove if it's equivalent, we should be able to multiply or divide each of the numbers by the same number and get the answer. For proving, I'm just going to write the first number, and I'm going to leave the bottom as a question mark. I'm going to then write, 3 times 4 would give me 12, and so to prove that this is equivalent, I'm going to do the same thing to the second number, 4 times 4, and I get 16. Since this 16 matches 16, we would say those are equivalent. Following the same process here for the second one, again, I'm going to ignore the second number, and I will just write a question mark. I know that 3 times 9 will give me 27, so I'm going to do 4 times 9 as well, and get 36. Because these numbers do not match, those are not equivalent. For the last one, I can see I have a smaller number first than the bigger, while here I have a bigger number first than the second, so we can cross that one off as well. The last application problem we did with ratios is being able to compare the two. So in this recipe, we have one person using, so Maria using 4 cups of sugar and 3 tablespoons of lemon, and Gemma using 2 cups of sugar and 1 tablespoon of lemon. Just like if we were comparing these as fractions, in order for me to say anything about them, we need a common value. Looking at my second number, I know if I double the recipe she used, 2 times 2 will give me 4, doing the same thing to the bottom. And so now we have a number in common in each of the recipes. So 4 for the amount of sugar. And so now we can compare the amount of lemon. And then we are able to say something about the taste. So when they're using the same amount of sugar as they are in each of these recipes, because Maria's recipe here has more lemon, we would say Maria has a more lemon flavor. So Maria has more lemon flavor. Hopefully this video helps you study for your unit test, covering all of what we have talked about in Unit 2 so far.